Question 1. Given the circumstances, Mr. Alvarez is commissioning a variable refrigerant flow VRF system in a commercial building where frequent load changes occur throughout the day. He notices that the system's inverter-driven compressor is cycling more often than expected, causing inefficiencies. What is the most appropriate step Mr. Alvarez should take to optimize system performance? A. Adjust the set point on the thermostat to a wider deadband. B. Increase refrigerant charge to prevent short cycling. C. Replace the compressor with a fixed speed model. D. Add supplemental electric heating to reduce cycling. Answer. Correct answer. A. Explanation. Adjusting the thermostat deadband allows the system to tolerate small temperature fluctuations before activating, reducing compressor cycling and improving efficiency. Increasing refrigerant charge indiscriminately can cause overcharge issues and is not a solution for cycling. Replacing the inverter-driven compressor with fixed speed negates CRF benefits and reduces efficiency. Adding supplemental heating addresses heating load, not cycling caused by control settings. Proper deadband tuning is essential in advanced ERF commissioning to balance load demands in compressor operation, optimizing energy use and system longevity. Question 2. In the context of an industrial refrigeration system, Is Chen finds abnormal pressure drops across the evaporator coils despite the system running at normal load conditions. Which of the following is the most likely cause and appropriate corrective action? A. Expansion valve stuck open. Clean or replace the valve. B. Refrigerant undercharge. Add refrigerant to system. C. Dirty coil fins causing airflow restriction. Clean the fins. D. Compressor malfunction causing low suction pressure. Repair compressor. Answer. Correct answer. C. Explanation. Dirty coil fins restrict airflow, leading to reduced heat transfer and causing a pressure drop across the evaporator. Cleaning the fins restores airflow and normalizes pressures. An expansion valve stuck open typically causes flooding, not pressure drops. Undercharge reduces system capacity but does not directly cause pressure drop across coils. Compressor malfunction affects suction pressure but not coil pressure drop specifically. Proper maintenance, including coil cleaning, is crucial to maintaining evaporator performance and overall system efficiency. Question 3. When considering the psychrometric chart, Mr. Patel is tasked with designing a ventilation system to condition air from 9-tided dry bulb and 60% relative humidity to comfortable indoor condition of 75 degrees and 50% relative humidity. Which process should Mr. Patel primarily focus on to achieve this change efficiently? A. Sensible cooling with dehumidification. B. Adiabatic humidification. C. Direct evaporative cooling. D. Sensible heating without moisture removal. Answer. Correct answer. A. Explanation. Reducing temperature and humidity simultaneously requires sensible cooling combined with moisture removal, dehumidification. Sensible cooling lowers air temperature, while latent heat removal reduces moisture content, moving the state point to the desired condition on the psychrometric chart. Adiabatic humidification adds moisture and cools, but is inappropriate here. Direct evaporative cooling cools, but increases humidity. Sensible heating raises temperature without affecting moisture, opposite of the desired outcome. Proper air conditioning involves simultaneous sensible and latent heat control. Question 4. Based on the information, Torres is troubleshooting an HVAC system where the compressor motor frequently trips on overload despite correct voltage supply and no visible electrical faults. What should Torres examine first to diagnose the root cause? A. Compressor start capacitor for failure. B. Refrigerant charge level for overcharge condition. C. Airflow over the condenser coil for restriction or blockage. D. Control thermostat calibration. Answer. Correct answer. C. Explanation. Restricted airflow over the condenser coil causes high condensing pressure, forcing the compressor to work harder and overload. This is a common mechanical cause of motor trips despite electrical conditions being normal. A failed start capacitor typically prevents motor start rather than cause overload trips. Overcharging refrigerant usually increases capacity but may cause other issues, not necessarily overload trips. Thermostat calibration affects cycling, not overload protection. Verifying condenser airflow is a critical step in troubleshooting compressor overload. Question 5. From a practical standpoint, Mr. Ibrahim must select the type of expansion device for a commercial refrigeration system that operates efficiently under varying load conditions and fluctuating evaporator pressures. Which expansion device is best suited for this application? A. Fixed orifice. B. Thermostatic expansion valve (TXV). C. Capillary tube. D. Manual expansion valve. Answer. Correct answer. B. Explanation. Thermostatic expansion valves modulate refrigerant flow based on evaporator pressure and superheat, optimizing system performance under varying load conditions. Fixed orifices and capillary tubes provide constant flow regardless of load, leading to inefficiency during fluctuating conditions. Manual valves require manual adjustment and are impractical for dynamic systems. ESES maintain superheat and protect compressors while improving energy efficiency, making them the standard choice for commercial refrigeration with variable loads. Question 6. Taking into account the fundamental principles of thermodynamics, Lopez is evaluating the coefficient of performance (COP) of a heat pump system operating between a cold outdoor temperature and a warmer indoor environment. Which factor most significantly influences the COP in this scenario? A. The temperature difference between the heat source and sink. B. The size of the compressor motor. C. The type of refrigerant used in the system. D. The duct material in the distribution system. Answer. Correct answer. A. Explanation. COP depends primarily on the temperature difference between the heat source outdoor and heat sink indoor. Smaller temperature differences reduce the work input required, increasing COP. Compressor size affects capacity but not directly COP. Refrigerant type influences system efficiency but less significantly than temperature lift. Duct material impacts air distribution losses but not thermodynamic COP. Understanding this principle guides design choices for maximizing heat pump efficiency in real-world conditions. Question 7. Under the assumption that a technician must ensure electrical safety when servicing HVAC equipment, which of the following procedures is most critical before beginning work on an energized electrical circuit? A. Use an insulated screwdriver to adjust components. B. Verify circuit energization using a multimeter or voltage tester. C. Wear gloves without verifying power status. D. Disconnect the neutral wire only. Answer. Correct answer. A. Explanation. Using insulated tools is essential but only after confirming circuit energization, so it is not the most critical first step. The most critical procedure before working on any electrical circuit is to verify it is energized with proper instruments. Working on energized circuits without verification is hazardous. Wearing gloves helps but does not replace voltage testing, disconnecting only the neutral one, as safe as the circuit remains live. The primary safety step is always verifying zero voltage before touching electrical components. Question 8. Considering the evidence, Johnson is asked to perform load calculations for a newly constructed residential building. The design requires estimating heat gain through windows. Which of the following best explains why accurate window load calculation is crucial? A. Windows are the primary source of heat gain from solar radiation and conduction. B. Windows contribute negligible heat gain compared to walls. C. Heat gain through windows can be ignored if HVAC system is oversized. D. Window shading does not affect heat gain. Answer. Correct answer. A. Explanation. Windows significantly contribute to heat gain via solar radiation and conduction, impacting cooling loads. Accurate calculation is necessary to size equipment correctly and optimize energy efficiency. Ignoring window loads leads to undersized systems or discomfort. Oversizing HVAC is inefficient and increases costs. Window shading can reduce solar heat gain substantially, so ignoring shading distorts load estimates. Proper window load assessment is critical for precise manual J-load calculations and energy-efficient system design. Question 9. Through careful analysis of refrigerant handling practices, Kim is implementing procedures for refrigerant recovery to comply with EPA regulations. What is the key principle he must adhere to during refrigerant recovery? A. Recover refrigerant only when the system is completely empty. B. Recover refrigerant to prevent release into the atmosphere and minimize environmental harm. C. Vent refrigerant in well-ventilated areas if recovery equipment is unavailable. D. Recovery is only required for systems using older refrigerants. Answer. Correct answer. C. Explanation. Refrigerant venting is illegal and harmful. A proper recovery prevents environmental damage. Recovery must be done regardless of system charge level. Not only when empty, recovery applies to all regulated refrigerants, not just older types. Venting refrigerant even in ventilated areas is prohibited by EPA. The fundamental principle is to use recovery equipment to capture refrigerants, ozone depletion and greenhouse effects. Compliance with recovery regulations protects the environment and meets legal requirements. Question 10. In light of recent developments in controls technology, HRConquer is integrating a building automation system BAS to optimize HVACR system performance. Which of the following capabilities of BAS most directly contributes to energy efficiency? A. Remote monitoring and fault detection to enable timely maintenance. B. Manual override of thermostats by occupants. C. Standalone operation of equipment without central control. D. Increased use of pneumatic controls. Answer. Correct answer. C. Explanation. Standalone equipment without centralized control cannot optimize system-wide energy efficiency, making this the least effective. Remote monitoring and fault detection enable proactive maintenance, reducing downtime and energy waste, enhancing efficiency. Manual overrides can disrupt optimized settings and reduce efficiency. Pneumatic controls are outdated compared to digital controls and generally less energy efficient. BAS systems improve energy use by coordinating equipment operation, scheduling, and optimizing set points based on occupancy and environmental data. Question 11. When analyzing a rooftop packaged HVAC unit, Mr. Williams notices uneven temperature distribution across different zones served by the system. Which of the following should he primarily investigate to correct the issue? A. Inspecting duct leakage and balancing dampers to ensure even airflow. B. Increasing the compressor speed to boost cooling capacity. C. Reducing refrigerant charge to prevent overcooling in some zones. D. Replacing the thermostat in the coldest zone with a newer model. Answer. Correct answer. A. Explanation. Uneven temperature distribution is commonly caused by airflow imbalances due to duct leaks or improperly adjusted dampers. Ensuring the duct system is sealed and properly balanced allows the correct volume of air to each zone, promoting even temperatures. Increasing compressor speed may overload the system and cause inefficiency without solving airflow issues. Reducing refrigerant charge typically reduces capacity system, not zoning issues. Thermostat replacement may be necessary for fault control, but is not the primary factor in airflow distribution problems. Question 12. Throughout the course of performing routine maintenance, Isnewen discovers oil foaming inside the compressor crankcase, leading to erratic lubrication and potential damage. What is the most likely cause of this condition? A. Excessive refrigerant in the oil causing aeration. B. Insufficient refrigerant charge leading to overheating. C. Blocked air filters restricting airflow. D. Faulty expansion valve causing low suction pressure. Answer. Correct answer. C. Explanation. Blocked air filters reduce airflow, causing evaporator temperatures to drop below the oil's boiling point, which can lead to refrigerant mixing with the oil and causing foaming. While excessive refrigerant in oil can cause foaming, airflow restriction is a common root cause. Insufficient refrigerant usually causes high discharge temperatures, not foaming. Faulty expansion valves affect system pressure but don't directly cause foaming. Proper airflow maintenance is crucial for compressor lubrication integrity. Question 13. According to recent studies, Mr. Brown is selecting refrigerants for a new system with both environmental sustainability and efficiency in mind. Which refrigerant characteristic most strongly influences the decision toward eco-friendly alternatives? A. High global warming potential (PB), low ozone depletion potential (OP). C. High flammability rating. D. High toxicity level. Answer. Correct answer. B. Explanation. Low ozone depletion potential is A critical environmental consideration in refrigerant selection as substances with high op damage the ozone layer. Refrigerants with low or zero op are preferred to meet regulatory standards and minimize environmental impact. High global warming potential is also important, but regulations often prioritize op first. Flammability and toxicity as safety but are managed separately and do not directly influence environmental sustainability classifications. Selecting refrigerants with low op is a foundational step for eco-friendly HVACR design. Question 14. In what ways can the integration of variable frequency drives (VFDs) improve the energy efficiency of HVAC motor-driven equipment as experienced by HRConquer in a commercial building retrofit? A. The VFDs allow motors to run at reduced speeds, matching load demands, lowering power consumption. B. VFDs improve the fixed-speed motor's torque without changing speed. C. VFDs increase motor speed constantly to prevent overheating. D. VFDs replace motors with pneumatic actuators for efficiency. Answer. Correct answer. A. Explanation. Variable frequency drives adjust motor speed to match real-time load requirements, reducing power consumption and wear. This provides significant energy savings compared to motors running continuously at full speed regardless of demand. VFDs do not just improve torque at fixed speeds but modulate speed itself. Constantly increasing speed is counterproductive and wastes energy. Pneumatic actuators are different technology and are not a function of VFDs. The flexibility of VFD control is essential in modern energy-efficient HVAC systems. Question 15. When faced with a refrigerant leak in a system, Mr. Martinez wants to minimize environmental impact and comply with regulations. What is the primary advantage of using electronic leak detectors compared to soap bubble methods? A. Electronic detectors provide higher sensitivity and faster leak detection, preventing large losses. B. Soap bubble methods are more precise in locating leaks than electronic detectors. C. Electronic detectors are less expensive and require no training. D. Soap bubble methods can detect leaks inside sealed components. Answer. Correct answer. C. Explanation. Electronic detectors offer greater sensitivity and can identify very small leaks rapidly, which is critical for environmental protection and regulatory compliance. Soap bubble methods are simple but less sensitive and slower, typically used for large visible leaks. Although electronic detectors can be more expensive and require training, their efficiency and accuracy provide long-term cost and environmental benefit. Soap bubbles cannot detect leaks inside sealed components and are limited to external pipe surfaces. Using electronic leak detectors supports responsible refrigerant management. Question 16. Under the assumption that Mr. Johnson is designing a commercial HVAC system, what is the most important factor to consider when selecting the appropriate duct material for indoor air quality, IAC, and longevity? A. Material resistance to corrosion and microbial growth. B. Material color to match the building aesthetics. C. Ease of installation without sealing requirements. D. Material cost only. Answer. Correct answer. A. Explanation. Selecting duct material with resistance to corrosion and microbial growth is essential for maintaining IAC and system durability. Corroded or moldy ducts can contaminate air and cause health issues, while aesthetics and cost influence decisions. They do not outweigh IAC considerations. Ease of installation is important, but ducts must be sealed to prevent leakage regardless of material. Choosing durable, cleanable materials ensures long-term performance and occupant safety, aligning with best HVAC practices. Question 17. To illustrate this point is Evans's troubleshooting a multi-zone HVAC system where one zone consistently reports poor temperature control despite correct damper position. What is the most logical cause of this discrepancy? A. Zone thermostat is not calibrated properly or located in a poor sensing position. B. The main compressor is undersized for the building. C. The refrigerant charge is too high. D. The building envelope has no insulation. Answer. Correct answer. B. Explanation. An undersized compressor affects system capacity for all zones, usually causing overall system failure rather than one zone specifically. Poor temperature control in one zone despite correct damper position often indicates thermostat calibration or placement issues. Incorrect thermostat readings can cause improper zone activation. Overcharging refrigerant affects overall system performance, not isolated zones. Lack of insulation impacts overall load, not single zone control. Accurate sensing and calibration are key to proper zone control. Question 18. In a modern context of energy efficiency, Mr. Sharma is asked to explain why heat recovery ventilation (HRV) systems are beneficial in tightly sealed buildings. What is the primary function of HRV in this scenario? A. Recovering heat from exhaust air to preheat incoming fresh air, reducing heating load. B. Cooling fresh air to prevent overheating. C. Increasing ventilation rates without regard to energy loss. D. Filtering indoor air contaminants. Answer. Correct answer. D. Explanation. Heat recovery ventilation systems transfer heat from exhaust air to incoming fresh air, significantly reducing the energy needed to heat or cool ventilation air in tightly sealed buildings. This reduces heating cooling loads and improves indoor air quality by ensuring constant fresh air supply. HVACs often include filtration. Their primary function is heat exchange, not contaminant filtration alone. Ventilation without heat recovery causes energy waste. Proper HRV design balances IC and energy efficiency effectively. Question 19. When faced with diagnosing a refrigeration system, Kim notices that the suction pressure is abnormally high while the condenser pressure is normal. Which system fault is most consistent with this symptom? A. Restricted or partially closed suction line causing pressure buildup. B. Overcharged refrigerant causing excessive pressure throughout the system. C. Dirty condenser coil causing high condenser pressure. D. Expansion valve stuck fully open. Answer. Correct answer. A. Explanation. A restriction or partial closure in the suction line causes pressure buildup upstream, resulting in high suction pressure readings while condenser pressure remains normal. Overcharging typically causes high condenser and suction pressures. A dirty condenser coil raises condenser pressure, not suction. An expansion valve stuck open causes low suction pressure due to flooding. Identifying line restrictions is critical to restoring proper refrigerant flow and system operation. Question 20. By evaluating system startup procedures, Mr. Lopez wants to ensure safe and effective commissioning of a newly installed HVACR system. Which steps should be performed immediately after verifying electrical connections and proper refrigerant charge? A. Perform a system leak test to detect any refrigerant leaks before operation. B. Turn the system on at full load to check for operational noises. C. Skip the initial run if pressure gauges appear normal. D. Begin preventive maintenance schedule. Answer. Correct answer. B. Explanation. After verifying electrical wiring and refrigerant charge, operating the system at full load helps identify unusual noises, vibrations, or operational faults early. This ensures components function as designed. Leak testing is essential but usually performed before refrigerant charging. Skipping initial operation risks undiscovered issues. Preventive maintenance scheduling occurs after commissioning is complete. Proper startup procedures are critical to system reliability and performance. Question 21. While examining a commercial HVAC system, Mr. Reed notices that the system's evaporator coil frequently freezes during moderate load conditions. Which of the following actions should he prioritize to correct this problem? A. Check and adjust the airflow over the evaporator coil to ensure it meets design specifications. B. Increase refrigerant charge to prevent freezing. C. Replace the compressor with higher capacity model. D. Lower the thermostat set point to increase system runtime. Answer. Correct answer. B. Explanation. Evaporator coil freezing often occurs due to low refrigerant charge or insufficient airflow. Increasing refrigerant charge without confirming the cause may lead to overcharge and system inefficiency. The priority is to verify airflow since restricted airflow causes coil freezing by lowering coil temperature. Replacing the compressor is premature without identifying root cause. Lowering the thermostat increases runtime. Worsens freezing if airflow or refrigerant issues persist. Proper airflow and charge balance are critical to prevent coil freeze. Question 22. Considering the evidence, Sanchez is selecting insulation materials for ductwork in a humid climate. Which property of insulation most critically affects its performance in this environment? A. Vapor permeability to prevent condensation within the duct system. B. Thermal conductivity to resist heat transfer only. C. Cost and ease of installation. D. Color to reflect radiant heat. Answer. Correct answer. A. Explanation. In humid climates, vapor permeability is essential to prevent moisture ingress into duct insulation, which can lead to condensation, mold growth, and deterioration. While thermal conductivity influences energy efficiency by reducing heat transfer, moisture control is paramount to maintain system integrity. Cost and color are secondary considerations. Selecting insulation with appropriate vapor barriers ensures long ductwork performance and indoor air quality. Question 23. According to the contemporary view of system controls, Mr. Lee wants to optimize HVAC system energy use by implementing demand-controlled ventilation (DCV). What is the fundamental operating principle of DCV? A. Adjust ventilation rates based on real-time occupancy measured by COS sensors. B. Provide constant ventilation at maximum design airflow. C. Cycle the HVAC system on and off at fixed intervals regardless of occupancy. D. Use manual override switches to control ventilation. Answer. Correct answer. C. Explanation. Demand-controlled ventilation adjusts airflow dynamically based on occupancy or air quality sensors, reducing energy waste when spaces are unoccupied or lightly occupied. Providing constant maximum airflow ignores occupancy and wastes energy. Fixed interval cycling does not respond to real-time demand and is inefficient. Manual overrides lack automation and precision. DCV systems rely on sense, optimize ventilation, improve indoor air quality, and conserve energy by modulating airflows intelligently. Question 24. In terms of heat transfer, Mr. Keller is analyzing a building envelope where large south-facing windows cause overheating in summer. Which heat transfer method primarily causes this issue? A. Radiation from solar heat through the glass. B. Conduction through the window frame. C. Convection from indoor air movement. D. Evaporation on window surfaces. Answer. Correct answer. B. Explanation. Solar radiation passes through glass, causing radiant heat gain inside, the primary source of overheating. Conduction through window frames transfers heat, but is minor compared to direct solar radiation. Convection relates to air movement and does not directly cause heat gain. Evaporation is not a significant factor in heat transfer through windows. Proper shading and glazing reduce radiant heat gain to control in temperatures effectively. Question 25. The underlying principle of Franken's refrigeration cycle design is to maximize efficiency. Which component operation has the greatest impact on the refrigeration system's coefficient of performance? COP. A. Proper expansion valve modulation to maintain superheat at evaporator outlet. B. Size of the evaporator fan motor. C. Material of the condenser coils. D. Color of the compressor housing. Answer. Correct answer. C. Explanation. While expansion valve modulation affects system performance, the condenser coil's material directly impacts heat rejection efficiency, significantly influencing COP. High thermal conductivity materials improve heat transfer and reduce condensing pressure. Evaporator fan size affects air movement but less directly influences COP. Compressor housing color is irrelevant to performance. Efficient heat rejection compressor work and overall refrigeration efficiency. Question 26. Given the circumstances, Mr. O'Neill must troubleshoot an HVAC system where the compressor cycles on high pressure cutout during humid days, but operates normally otherwise. What is the most probable cause? A. Dirty or blocked condenser coil reducing heat rejection. B. Low refrigerant charge causing system inefficiency. C. Thermostat malfunction causing premature cycling. D. Faulty expansion valve stuck fully open. Answer. Correct answer. A. Explanation. High-pressure cutouts on humid days are often due to reduced condenser capacity caused by dirty or blocked coils, impairing heat rejection and increasing condensing pressure. Low refrigerant charge usually lowers system pressures, not raises them. Thermostat malfunctions affect cycling frequency but do not cause high-pressure cutouts. An expansion valve stuck open causes low suction pressure and flooding. Cleaning condenser restores heat rejection, preventing pressure trips. Question 27. In light of recent developments, is Morgan integrates advanced sensors in a building automation system BAS Which sensor type is most critical to accurately monitor indoor air quality? A. Carbon dioxide co-sensors. B. Temperature sensors. C. Pressure sensors. D. Humidity sensors. Answer. Correct answer, D. Explanation. Co-sensors are essential for occupancy-based ventilation control, but humidity sensors directly influence comfort and microbial growth, critical to HVAC. Temperature sensors help control climate but do not measure pollutants. Pressure sensors monitor airflow and system balance. Humidity sensors detect moisture levels that affect mold growth and occupant health, making them vital for HVAC management. Integrating multiple sensor types yields the best HVAC performance. Question 20. For many years, Castillo has designed duct systems in commercial buildings. Which of the following best explains why duct leakage testing is vital during installation? A. It prevents energy losses by ensuring air delivery matches design specifications. B. It improves the structural integrity of the ductwork. C. It guarantees the duct material will not degrade over time. D. It reduces the noise generated by the HVAC system. Answer. Correct answer, C. Explanation. Duct leakage testing primarily aims to identify and seal leaks to prevent energy losses and ensure design airflow delivery, which improves system efficiency and occupant comfort. It does not directly affect structural integrity, material durability, or noise generation. While sealing leaks may reduce noise slightly, this is a secondary benefit. Confirming airtight ducts is essential for meeting energy codes and operating costs, supporting sustainable building design. Question 29. When faced with a diagnostic challenge, Patel measures an abnormally high superheat at the evaporator outlet. Which condition is most consistent with this observation? A. Undercharged refrigerant system causing insufficient refrigerant flow. B. Overcharged system causing flooded evaporator. C. Blocked air filters reducing airflow. D. Expansion valve stuck fully open. Answer. Correct answer, A. Explanation. High superheat indicates that refrigerant is fully evaporated before leaving the coil, typical in an undercharged system or insufficient refrigerant flow. Overcharged and flooded evaporator cause low superheat. Blocked air filters reduce heat transfer but often lead to coil freezing and low superheat. Expansion valve stuck open causes flooding and low superheat. Diagnosing high superheat is critical for correct refrigerant charge and system performance. Question 30. In a geothermal heat pump system installation, Simmons must ensure proper ground loop design. What is the key factor influencing ground loop efficiency? A. Soil thermal conductivity and moisture content around the loop. B. Size of the heat pump compressor. C. Type of refrigerant used in the heat pump. D. Location of the thermostat indoors. Answer. Correct answer, B. Explanation. Soil thermal conductivity and moisture content directly affect how effectively heat transfers from the ground loop, determining system efficiency. Compressor size influences system capacity but not ground loop heat transfer. Refrigerant type impacts overall heat pump performance but not the loop itself. Thermostat location affects indoor comfort control but not ground loop efficiency. Proper ground design matches soil conditions to optimize geothermal system performance.